Chapter 5, Day 3. I'd like you to see if you could do this warm-up on your own. This is finding the rate of change for each time interval and finding out when the price increased the most compared to the time interval. So pause the video, give it a try, and then restart the video to check your work. So here should be the answers for each time period. Okay, you have these changes, but over different time periods. So when you factor in the time period that the change was occurring, this is the time interval when the price increased the most, and that was from 2016 to 2017. Those, this is a mistake right here. Whoops, this should be 2018. And that is our year or time interval years where the price increased at the most per year. So hopefully that is starting to make sense, because that rate of change is really what we're going to be talking about today, which is slope. So we're going to describe slopes of lines. We're going to talk about positive, negative, zero, undefined, and we're going to find the slopes. We were finding the slopes for a certain time period and average rate of change. We're going to do it from a graph and ordered pairs this time, which you could really get from a table as we were doing before. So here's the first thing we're going to look at. Slope is a rate of change in the y values to the change in the x values. So again, it is the difference in the y values compared to the difference in the x values, and we refer to those y values as our rise and our x values as the run. So this is something you probably worked on before, but slope is rise over run. This symbol right here refers to change. So that represents change in y. So the change in y compared to the change in x. All right. So here's pictorially, or with the picture and graph, what this looks like. So when we were calculating all those changes for a given time period, okay, we had some different ordered pairs. The difference here is because this is linear, it's going to be a constant change. So the rise right here is the difference in the y values. So when you go from this point right here to this point right here on the graph, you are looking at how far you're rising. So it's really the difference between this y value and this y value, and that's how we calculate it. Okay, the run right here is the difference in the x values. So when we go from those 2 points, the difference in the x values is going from here to here. And so that difference is this right here. And that's how we calculate our slope of the line, is the ratio of rise to run for any 2 points on the line. So this is really what we said on the last one, but remember here that y is the dependent variable, x is the independent variable. So that just goes back to our work with chapter 4, functions in general. So again, the rise is the difference in the x's, and the run is the difference in, the rise is the difference in the y's, and the run is the difference in the x's. So let's talk about how we do that. And we use this the letter M to represent slope. You might have remembered that from the past. So we can define slope as positive, negative, zero, or undefined. And we talked about this when we first started this. If our line is increasing from left to right, when we look at this graph from left to right, that is our positive slope. That's going to be increasing. So that's going to be our positive slope. If it's decreasing, like the next one, it's going down. Now it's decreasing. And that's going to be negative slope. Remember from before, when we had a change like this was no change, and we called that constant. And so our slope there is actually 0. And this is highlighted over here, this z, because sometimes students are kind of look at the z part and kind of relate it to that horizontal line. If that helps you, great. Okay, but that is going to be always going to be 0. And last but not least, this last graph right here, when we look left to right, is increasing at such a fast rate or decreasing at such a fast rate that we say the slope is undefined. So one of the ways that I remember the 0 versus undefined is when I think of slope right here, I think of like a ski slope, okay? And if you are standing at the top of this hill, ready to ski or snowboard down, okay, there's no like momentum you can get because it's flat, okay? And so that's 0. But if you are standing up here, okay, now you're like, whoa, that's too steep to define. So this is too steep, and that's why we call it undefined. Versus this 0, there's like no slope. But we really don't use that word, but like it's so small, okay? So maybe that's better. It's so small, it's 0. So it's like too small to actually like measure. So if again, any of those things help, great. If not, then you can certainly just remember that. All right, so again, these are the two tricky ones, and this is the ones I just talked about. You could use that Z in there to help you, or you could use the picture to help you of which is which. Again, this is too steep. This is small. This is very small slope. And that's too steep to define. All right, so we're going to find the slopes of these lines. Okay, I'm going to start working through some with you, and then you are going to try some by pausing the video and etc., just like we've been doing. All right, so the first one we're going to do right here is we're finding the slope between this point and this point. So it doesn't really matter which point I start with. Okay, I usually like to start with the one on the left and work to the right. So if I do that, then I am going up. I am rising. How far am I rising? Okay, well, from this to this, my rise is going up. Now notice that this is going up, skipping spaces. Okay, so you're really rising just 1, 2, 3, 4. So your rise is 4. Well, actually, I'm sorry, because of the spacing, your rise is actually 2. So our rise is 2 right here, and our run is 1. So our slope is rise over run, and so it is 2 over 1, which is equal to 2. Now, if you're counting the spaces, okay, so if you count these spaces, you're counting 1, 2, 3, 4. So when you're counting the spaces, you get 4 over 1, 2, which is the same as 2 over 1. So it works out the same. If I were to start at the other point, then I would be going down, which is a negative right there. So that's where you can see that if we look at this the other way, starting with this point, now we're going down and we're going left. And that's why we get -2 over -1, which would still be the same slope of rise of -2 over -1, which is still a slope of 2 or 2 over 1. So why don't you see if you can do letter B? Pause the video and then see if you got it correct. Okay, so for this question, again, I like to start on the left side right here. And what's happening here is I am going down. So my rise is actually a negative number. I'm going down, that's negative. I'm going up to get to the next point, it's positive. And I am going down 3, okay? My run, I am going over, so it's positive. I'm going to the right, so it's positive, and it's 9. So I get a rise of negative 3, I get a run of 9, and so that is the same as negative 3 over 9, and we always reduce our slopes, so that would be negative 1/3 if you got it correct. All right, so your turn. Again, let's see if you can do letter C. Pause the video and then restart it, but why don't you go ahead and try D at the same time? So try C and D. Then restart the video to see if you got them correct. All right, in question C, if I start at this point right here, okay, and go to this point right here, my rise actually is going down. I'm going down 2, and I'm going 1, 2, 3 over, so plus 3. So my rise is going down 2, and my run is 3, so that is negative 2/3. That should be what you got for your slope. Now, if you did letter D correctly, maybe you just memorized, maybe you remembered horizontal with the Z, but this is actually 0 slope, okay? And you can look at it still as rise over run, and I'll show you how. If you start at this point right here and go to this point right here, your rise is 0. You don't go up or down at all, and your run is 2, and that still is the same as 0. All right, I have a couple more for you to try. Why don't you pause the video, try these 3 questions, and see how you do when you restart the video again. All right, for this one right here, if you again start at this point right here, that's my starting point. I am going rise of 2, run of 1, so you should have gotten 2 over 1 or 2. For letter F right here, okay, this is the one where you're standing at the top and you're going, oh no, it's too steep to define. This is the undefined one. Or you can just memorize those. And last but not least, letter G, you are going 1, 2, 3, 4. You're going rise of 4 and a run of 3. 1, 2, 3. So your slope is 4/3. All right. So I'm just going to double check that, but that looks right. All right. So we know slope is rise over run. Okay. So we can actually get that from the ordered pairs. All right. So let's go back to this one that we did and notice that there are 2 ordered pairs here. Okay. Let's use those 2 ordered pairs to take a look at how we got that 4. So if you look at and remember, it's the change in the y values. You're going from this part to this part on the y value, which we counted was 4 spaces. But look at the y value. If you go from -1 to 3, how many spaces have you gone? 4 spaces. Because you're really taking the difference of those numbers. You're taking -1 and you're subtracting 3, which is going to give you -4. Now when you look at the x values, your x values, you are going from this point on your x-axis right here over to this point on your x-axis, and so you are going from -2 over to 1. So -2 minus 1 is -3, and that slope is the same as 4/3. So we don't actually have to have the graph. We can use the coordinates or the ordered pairs, and we can take the difference in the y's compared to the difference in the x's. The key is you always have to start with the same x or y value from that ordered pair first. So this is how we kind of look at it, is with this slope formula. We take y2 minus y1 over x2 minus x1. And again, when I take y2 minus y1, that's really our change or difference in our y values that we defined already, and this is our change or difference in our x values. So again, you can look at these things in words. The slope of a line is the ratio of the difference in the y values to the difference in the x values between any 2 points on the line. And that leads to this formula. Take your 2 ordered pairs, label the first ordered pair with x1, y1, and the second ordered pair x2, y2. The 1s and the 2s just represent the first and the second ordered pair. And then the difference between them is y2 minus y1 over x2 minus x1. That is our slope formula that we have right up here. And then they give you an example to work through, but we're going to work through some other examples together. But this is a good thing to look back to and to see if you can make sense of it. So find the slope of the line that passes through the following points. Okay, so we have our slope formula here so that we don't have to think through. You should always keep this out and not make sure you're not making a mistake. So how I like to start these so I don't make a mistake at the beginning is I label these. This is x and y, my first ordered pair listed, or the first one I'm looking at. This is x and y. This is going to be my second one. You could switch those two around. It won't matter. You'll get the same answer. So now I'm going to take my y2, 0, and my y1 and plug them in. So this is going to be 0 minus 10 over my second x value, which is 2, minus my first x value, which is negative 4. Now don't forget that you have to subtract this x value right here. So you're subtracting that negative 4. So now that's going to simplify to 0 minus 10, which is negative 10, over 2 minus a negative 4. Remember, add the opposite, and that gives you 6 on the bottom. So that gives us a slope then. When we reduce that fraction, that gives us a slope of, we can divide by 2 on each side, so that gives us negative 5/3. That is the slope of that line. Okay, I'll do the next one. Actually, you do B. You pause the video right now and you try to plug in the correct values. Then check back to see if not only you plugged in the correct values, but that you did the subtractions correctly and the simplifying if need be. Okay, so again, it's really helpful to label those so that you make sure you're subtracting things in the correct order and plugging the numbers in correctly. Then what you should get for your slope is 11 over 5. Let's do letter C together, because this is one of those ones that gets a little tricky. So again, we're going to label these, and then we're going to just plug them in. So my y2 value is 4. My y1 value is also 4. My x2 value is 0. Subtract my other x value, which is negative 12. Don't forget that. So what is 4 minus 4? That's 0. Divided by, and then this becomes positive 12. And here's where you can check it on your calculator, but what is 0 divided by 12? Well, my slope is 0. But be careful, because if this had been 12 divided by 0, if 0 had been on the bottom, that would be undefined. And if you do that on your calculator, you would get an error message, and that's how you kind of can tell. All right, I have one more thing to cover with you, and that's just relating slope back to sort of real world applications and rates of change. It says find the slope of the line, and what does the slope mean? Okay, well, we have these 2 ordered pairs, so we can find the slope of the line. Okay, so I am going to label these ordered pairs just as I've done in the past. This is my first ordered pair, and this is my second ordered pair. So now I take my second y value right here, 17, and subtract my first x value, which is 11. Divide that by my second x value, 6, minus my first x value, 2. So that gives me 17 minus 11, which gives me 6 for my rise and 4 for my run, which is 3 over 2. So this is the slope of the line. But what does it really mean? Well, what it means is you are rising, okay, And what that is your salary. Okay, so you are rising a value of $3 per hour, $6 per hour for every 4 years. Your run is the number of years going from here to here. So what it means is that in 4 years' time, your salary has risen $6 per hour. So what that means is that your salary rose $6 per hour in 4 years' time. So if we reduce that as an average, it would be $3 per hour in 2 years. And how many per 1 year? Well, that would be $1.50 per year on the average. So that's how that kind of relates back to that average rate of change. So that's what the slope represents. It represents the change in dollars per hour compared to the number of years you've been working at that job. All right, that is the end of this